Hi, my name is Theo, and this is my IoT Environmental Monitoring System built around Arduino Nano and ESP8266 Wi-Fi module. Now, this system uses three sensors: a DHT11 used for temperature and humidity, LDR for light detection, and then PIR sensor for motion detection. And they log everything into a cloud on things speak. Now, my research question is, how does indoor temperature, humidity, light intensity, and infrared occupancy vary over continuous 48-hour period, and what measurable correlation exists between them? What I'm going to show you today is a system that works end to end and walk you through how I'm going to make sure that the data that is collected is actually valid and it is usable for my research article. Here's the actual build. Arduino Nano is the controller, and DHT11 is connected to digital pin 8 with 10 kilo ohm pull-up resistor on the data line, since it's a base sensor rather than a module with one built-in. And then the PR sensor goes directly to pin 8, and LDR analog, LDR, yes, here it is, analog output, it feeds directly to A0, and then the Wi-Fi module, here it is, with handles the Wi-Fi connection over the serial, and then also using the capacitor here to protect it from the high voltage that comes from the Arduino. Now that I've shown you the build, it's time for me to show you whether it works or not. Well, let me plug it in. Now, as you can see, LED for each department is on. Now we're gonna be switching on the light on and off, and for the temperature and humidity, and for the motion. Now, this is what's happening on ThinkSpeak. Currently, the data is being updated in real time. As you can see, the temperature on field 1, the PIR pulse on field 2, and then for the light on pin 3, on field 3, and then for humidity, it's on field 4, since I'm in the same room and there's little to no humidity. Now, all of this is being updated in real time, meaning this is corresponding to that. As you can see, for the movements, the pulse, there it is. And then for the light, we just turned it on. Now, if we turn it off, and as you can see, it is, the last entry was less than a minute ago. So everything is happening in real time, corresponding with what this circuit is doing. Now, how am I gonna make sure that this data is valid and usable for my research article? Well, I'll run the system continuously for 48 hours, sampling every 30 seconds, and that works out roughly around 5,760 readings per field over a full run. Now, before that full run, I validated each sensor individually. I checked the DHT11 against the reference thermometer. I tested the LDR by shining a torch on it, and I also confirmed the PIR triggers on deliberate movement. So I know that each sensor is reading something before I trust the data it produces. Now, because the PIR only detects motion, not presence, I'm not reading the raw PIR signal as occupancy. I've defined occupancy formally. Now, the room counts as occupied if motion was detected within the last 120 seconds. Now, to check that this actually reflects reality, I run at least 30-minute manual observation session during that 48 hours. Yeah? And then I'll log the true occupancy myself to compare it against the PIR derived on the field. After the run, I'll go through ThinkSpeak dataset and screen it for missing entries, flatline readings, and obvious ADC outliers before I use it. Well, that gives me a clean, continuous dataset I can run time series and correlation analysis on, checking things like how light and temperature relate to occupancy, and whether there are clear daily patterns which is exactly what I need to answer my research questions. Now, with nearly 700 data points collected, I'll generate a time series to plot and reveal patterns of temperature and light rising during the day, falling at night, plus occupancy following human activity. Now, the correlation matrix will show the relationship between the variables, temperatures versus humidity, light versus occupancy, temperature versus the time of day. And then this will directly answer what correlation exists between these indoor environmental parameters over continuous 48-hour period.